Hello everyone. This is regarding submission for the hackathon President Care Challenge 2023. This comes under the problem statement 4, which is cybersecurity and detection of unencrypted data containing PHI and PII. In this, what we'd be diving into is building a solution which takes care of automatically removing and detecting all the PII information from logs such as from healthcare information logs or device log or any unencrypted log. This can be as logs were used for maintaining what has happened and maintaining the history of what activity has taken place. Here, our basis would be on getting an unbiased and decentralized ownership of the data. So that's what we would be aiming towards. What we'd be building is basically the solution is built using Python. Python is the main programming language built here. Problem statement can be phrased into 6 points, and these are simple problems which are broken down from the main problem. So one is to pass data from the logs. The parsing one which we must take care of structured and unstructured or maybe custom data. We should provide. We also aim to provide custom data readers for parsing. It may be, for example, internally, G uses a different kind of data to store logs, and this useful for as a product. And we would be fine tuning and training necessary ML models, but and to do NER. NER is named entity recognition. So what NER does is actually it identifies entities in the context of NLP, natural language processing. It is basic. It is like any named entity is a real life object which has an identification and can be defined by name. And this can be an IP address. This can be anything which can be used to trace back to the person. Doing is do or make a ML model which performs NER with the PHI and PII information. We would be identifying the PII, and first we'd be using rule-based recognition because the regular expression of an IP address it doesn't change; it exists the same. It can be easily traced back instead of going for the ML solution. Instead of taking the processing time, it can directly be parsed easily using regular expression. First, you'd be matching using regular expression and rules, and then we would be going for different stacking of a mixture of models to get the highest performance. And we'll be also storing the PI information as a log. So this log will be also stored in a database, and this can be used to anonymize the data using the identified PII. And this also uses a catch for faster access to rules. Our idea is unique, and how the actual solution takes place is, so this is the architecture diagram. So I'll be basically giving a gist of the architecture. First we'll be feeding in data. This data will be processed by logs reader. So one of the for example, it can be any type of log, and the other type is unstructured data reader. The logs might not be structured. The logs might for example, one equipment might provide a log which uses entity as a. The second device would give you the with entity d. So a and b might not be as same. A and b might be unique. So we will build a custom structured and structured data reader which can parse everything. So this is where the parsing of data comes in. And we would be so what will this the application will be REST based. So you would have API to access each and every point of the system, so that you would easy for integration, and also easy for us to develop. And first, as I said earlier, it would go into rule-based redaction. So rule-based redaction in here means the rules and everything. So these rules are uh, basically it can be regular expressions and NER based reduction. So in this NER based reduction, we will be using Spacey library to do the NER recognition, and Presido and PII long form. So what Presido is actually an open source implementation of from Microsoft. This is for basically what Presido does is it helps ensure sensitive data is managed. And this was built by Microsoft, and it is an open source. There is also the PII long former. So what PII long former is basically, the long form is a advanced version of the modified version of transformer mod architecture. So what happens is that when transformers are used, the attention pattern scales uh, quadratic, or but in long format it squares linearly with the sequence length, making it easier to process documents of thousands of token length. And we will be using QLoRa to fine tuning. So what QLoRa is basically, it's a fine tune method that combines quantization and low rank adapters. So this was built on top of LoRa. LoRa was also uh, used for fine tuning large language models (LLM). So here, what we is this thing, what it does is it enables fine tuning on massive models with billions of parameters on relatively small and highly available GPUs, which are no, basically these highly available GPUs can be used for training. So you need not have a big data center to process, and you not need not have a 500 or Tesla 100 series of GPU to process. You can basically run it using a NVIDIA 3060. So this is where the QLoRa fine tuning comes in. So and the next one is debata. So what debata is actually decoding enhanced BERT with disentangled attention. So what it does is it basically improves on BERT. BERT is also NER. BERT is a large language model, and it also builds on top of Roberta. And what it does is it basically is is a decoding enhancement for BERT with with this entangled attention architecture. So what it does is it makes fine tuning for handling PII easier, and it also is used for identifying highly suitable. This is highly suitable for identifying and processing of sensitive data, PII data. The sensitive data in context is PII data. Yeah. And we would be redacting the mapping, and we would basically from this would be the PI detection engine, and the detection engine will also give the redaction mapping. For example, a name or a patient's name has been identified, or a consumer name has been identified in location 0 to 16. So we would be getting this mapping. So this creating so we'll be creating log, and we'll also have a cache based retrieval. So this is where the cache based retrieval comes in between, and this is for the database for PII mapping. So while we are giving it back to the application, what it does is we replace this PII with an anonymized data. So this is where the main goal comes in, and this is the solution for the hackathon. And the main thing is basically the core of our project is to make patient privacy and details automatically be sent over each other, and to search towards decentralized ownership of data to build secure multi-party computation, SMPC. So this is what we've built to achieve. And thanks for joining me with this presentation. So this will finally be a win-win with patient privacy as well as the healthcare security. And this also uncovers the cybersecurity part, as we are interested with the unencrypted data, which will we be identifying the PII information. Thank you.